to Science with Hannah. Today we'll be learning about pure substances and mixtures. Now you may have noticed I've got two glasses of water in front of me. One is from the sea and one is pure water. But before I start drinking them, I want to know which one's which. They look kind of identical. How could I tell? Join me in today's learning journey and you'll find out. Today's lesson is based on our Strand 4, the world of materials. By the end of today's lesson, you should be able to identify some familiar materials as pure substances or mixtures, compare the properties of a pure substance with a mixture. For today's lesson, you'll need a pen, your notebook, and your curious mind. Now, did you know that everything that you breathe, see, eat, or touch is made up of chemicals? All matter, including us, is made of chemicals. Chemistry is just the study of the composition, what it's made up of, the structure, how it forms, the properties, what it looks like and does, and reactions, what other things that it will react with, of all matter. Now, all matter is made of atoms. We can think of atoms a bit like building blocks, a little bit like this piece of Lego. Atoms can be joined in all sorts of weird and wonderful ways to make chemicals. I'm going to show you this now by making some water. Now, do you know the chemical symbol for water? If you guessed H2O, you'd be correct. H stands for hydrogen. We're going to make blue hydrogen here, and O for oxygen. So if I join one blue or one hydrogen to one pink or one oxygen to another blue or another hydrogen, I make water. Water is an example of a compound. They're elements or atoms that are joined together. If I think about just pure oxygen, then oxygen is an example of an element. I could build it like with just these pink blocks. Both water and oxygen are both examples of pure substances. There's only one type of Lego block or one type of particle that they're made from. A mixture, however, has got all sorts of weird and wonderful parts to it. So it might look a little bit more like this. Lots of different colors, lots of different types of particles. Are you ready to explore some more? Now today, you are all scientists, which means we're going to make some observations. I'll get you to write down what you see and some inferences, some educated guesses. In front of me, there are 3 different stations. Each station has an example of a pure substance and a mixture. We'll start at station 1. Can you write down some observations in your book? Can you make a guess? Is A or B the pure substance? Let's move to station 2. Again, one of these is a pure substance and one of them is a mixture. Can you write down some observations in your book? Now make a guess. Which one is the pure substance? Is it A or B? And finally, we'll move to station 3. Again, one is a pure substance and one is a mixture. Now this one's a little tricky because if you look closely, they look pretty similar. So I'm going to give you a hint for this one. I'm going to taste them. A tastes pretty much like water. Ooh, B tastes very sweet. Which one do you think is the pure mixture? Pure substance. And which one do you think is the mixture? Now, if we go back to station A, if you said that A was the mixture and B was the pure substance, you would be correct. B is a pure substance, it's just water. A is a mixture though, because we can see quite clearly that there are two different layers. This is a combination of oil and water, and oil and water don't mix very well. So you can see that even when I shake this, the oil and the water stay separated. A is an example of a mixture. If I go and look at station 2, A this time was the pure substance. If you look closely, then in B, you can see that there's little specks. This is actually just some sand that I collected from the beach this morning. And sand is a mixture of lots of different types of particles. Whereas A, this one, quite heavy. This is pure iron. Pure iron is an example of an element. It's just one type of atom, one type of building block. And our final one, A tasted just like regular water because it is plain water, but B is some water that's had some sugar stirred into it. Though you can't see it, B is a mixture because there are two different chemicals that are combined. We can separate them, they're not chemically combined, so therefore B is the mixture. So what does this mean for pure substances and mixtures? We can divide all matter into pure substances and mixtures. Pure substances are made of only one type of particle, and it can be an element, a bit like oxygen or gold, or a compound like water or carbon dioxide made of two different types of atoms. These cannot be physically separated and have fixed properties like melting point or freezing point. A mixture, however, is two or more substances that are mixed but are not chemically combined. This means that mixtures can be separated by physical means. Mixtures can be homogeneous, which means that they look the same throughout them. A little bit like our sand, right? It looked the same even though it had specks through it. Or they can be heterogeneous, which means that they look different throughout. An example of that was our oil and water because the oil sat on top. So now you know a little bit about mixtures and pure substances. Can you guess if these everyday objects are mixtures or pure substances? Write 1 to 5 down in your notebook and answer them for me. Now for the answers. The first one, coffee, is a mixture. It's an example of a homogeneous mixture because when you mix coffee in, as long as you've stirred it properly, it should look the same throughout it. The second photo was of a gold ring. Gold is of course a pure substance, and it's an example of an element. A third one, milk. Milk is a mixture. Milk has lots and lots of different things in it, like proteins and fats. It's a homogeneous mixture because they're all mixed throughout it. It looks the same. Salt is an example of a pure substance. Salt is made up of two elements, sodium and chloride, so it is an example of a compound. And finally, a chocolate chippy biscuit is an example of a mixture. Chocolate chippy biscuits are heterogeneous mixtures though, because they look different throughout them. To end today's lesson, we're going to do an experiment that you can do at home. For this, you'll need 2 glasses, half filled with water, and you'll need to check that they're okay to go in the freezer. You'll need some salt, you'll need a teaspoon, and you'll need a pen or a marker. We're going to make a mixture, and we're going to use that mixture to test some properties. Specifically, we're going to test the freezing point. Freezing point means at what temperature does a substance freeze at. Now for this experiment, you're going to start by labeling your 2 glasses. I'm going to label this one salty. And I'm going to label this one as pure. If you don't have a pen you can label them with, just label them with a piece of paper, put a piece of paper underneath them. Now we're not going to do anything to the pure one because this is just pure water, but we are going to add some salt to the salty one to make it salty. So take 2 teaspoons of salt and add them to your salty water. Now once you've added, you'll need to make sure that you give it a really good stir so that the salt dissolves. That's it. Now I'm going to go and put these in the freezer, and I'm going to look at them after half an hour, after 1 hour, and after 2 hours to see if there's any change in between them. I'm expecting that they're not going to freeze at the same time, so that they have different freezing points. So what did we learn today? We learned that all matter, that is, everything in the world, is made up of atoms or building blocks that make chemicals. Matter can be classified as a pure substance made of only one type of particle, or as mixtures made up of multiple types of particles. Only mixtures can be physically separated, and pure substances and mixtures can have different properties. Now next time we'll learn about some common techniques that scientists use to separate mixtures. Thank you for joining me today. Anyway, I'm off to go and freeze this water and see what's safe for me to drink. Pa soi fua.
E whaitau wafe tina matamaitai o le lalolangi ua afia mamaliliu I le kānesa o le ngutu o le toala whānau o tamaitai po o le cervical cancer. I totono Samoa, ua maitauina e le matanga luenga o le soifua maloloina le siitia o le numero tina matamaitai ua maliliu ona o le nei kānesa. O le HPV po le human papillomavirus o se vairasi e taatele, e maafua ai le kānesa o le ngutu o le toala whānau o tina matamaitai. O le 10% o tina matamaitai e afia I le vairasi o le HPV, e te le avanua e ono mauai I le kānesa o le ngutu o le toala whānau. O le puipuinga sili o le nei kānesa, o le whai o le tui puipui o le HPV. Go Tene! Let's do it for Samoa!
Te me te me tau tina. Le nei vai tai me o le tele o suinga o tau. E ono tula e mai ni whalawlawe mātu ia. E a whai nai le ola, marasaunga le mu o tātou hainga. O nisi nei o vaenga, e ta tau